Hello dear SE students, welcome to the mathematics classroom. Today we're going to discuss three topics: the simple interest, compound interest, and annuities. By the end of this chapter, you'll be able to calculate a simple interest, calculate the future value of a simple interest, which is also called the acquired value, calculate the future value of a compound interest, the future value of a series of annuities and the gained interest, calculate the present value of a series of annuities and the paid interest. Start our chapter with an activity. Nadim and Fadi are two brothers. Each one of them has 10 million Lebanese liras. They decided to place their money in a bank in two different accounts. Nadim decided to place his 10 million at a simple interest rate of 10% for 3 years, while Fadi decided to place his 10 million at an annual interest rate of 9% compounded monthly for 3 years also. The question is, who between Nadim and Fadi will earn more money at the end of the 3 years? Think about it first, and during this presentation, you will learn who, how, and why. In part 1, we're going to define the simple interest. It represents the additional amount of money paid as a fee for a loan or earned as an income for a deposit. The notation of the simple interest is I, and it is given as I equals PRT, where P is the initial capital, deposit, actual value or loan, R is the annual interest rate, and T is the time in years. If you want to define the acquired value or the future value, then it is the sum of paid or earned money at a future point in time for a given interest rate. The acquired value is denoted as F, and accordingly F is P plus I. P is the capital or the initial capital, and I is the interest calculated above. So F is P plus I, which is equal to P into 1 plus RT if we just replace I by its value here. As an application, let's do this exercise together. Calculate the interest and the future value of a capital of 5 million Lebanese liras placed at a simple interest rate of 10% for 2 years. First, we need to identify the given. P, which is 5 million, it is the capital. R is 10%, which is 0.1, and T is 2, which is the time in years. So the interest is I equals P times R times T, which is 5 million, this is P, times 0.1, which is R, and times 2, which is the time in years. This is equal to 1 million Lebanese liras. Now to find the acquired value or the future value, it is F equals P plus I. So it is the 5 million, which is the principal value, plus 1 million, which is the interest calculated. This is equal to 6 million Lebanese liras. Note that sometimes the time is given also in months, in days, or in weeks. In this case, the formula has to be modified. So the simple interest will be computed. Suppose it is given in months. The simple interest is computed by the formula I equal P times R times T over 12. So we have replaced T by T over 12 in order to replace so that we can substitute for T its value in months. In this case also, the acquired value is given by the formula F equal P plus I, and we replace I by its value, so we get P into 1 plus R times T over 12, where T in this case is in months as we have said. Let's apply it. Suppose that we have to calculate the interest and the future value of a capital of 5 million Lebanese liras placed at a simple interest rate of 10% for 24 months. So the solution is, again, P is 5 million, R is 10%, which is 0.1, and T is 24. The interest is then I equals P times R times T over 12. And here we replace T by 24 since we have 24 months. Substituting, we find that the value is 1 million, which is equivalent to the previous exercise, since in the previous exercise we had 2 years and 24 months are equivalent to 2 years. Finding the future value, again we write F equal P plus I, which is 5 million plus 1 million, which is 6 million Lebanese liras. What if we are given the time in days? Okay, again here, if we are given an ordinary year, and now we're going to see the difference between an ordinary year, a leap year, and a commercial year. In this case, the simple interest is computed by the formula I equal P times R times T over 365. So here we have T can be now substituted in days. The acquired value is computed by the formula F equal P plus I. We replace I by its value again, and we take P as a common factor. So it's P into 1 plus R times T over 365. Here T is the time in days of an ordinary year. Days during a leap year. In a leap year, we know that the number of days is 366. So we just replace this by T over 366. Okay, we replace T by T over 366, and now we can write the time in days. But here we have to make sure that we are working with a leap year. In a commercial year, the number of days is given to be 360. So this is T over 360. T over 360 is why? Because we have 360 days in a commercial year. This is also followed by banks. Let's apply it in an exercise. Calculate the interest and the future value of a capital of 5 million Lebanese liras placed at a simple interest rate of 10% for 183 days of a leap year. So here we are given a leap year, so we should know which formula to use. We just use the formula which shows that I equal P times R times T over 366 because we have a leap year. So P is 5 million, R is 10%, which is 0.1, and T is 183. We just replace each letter by its value, and we get that the interest is 250,000. If we need to find the future value, then F equal P plus I, which is 5 million plus 250,000, which is 500 million, 250,000 Lebanese. What if the time is given in weeks? We know that in a year we have 52 weeks. In this case, the simple interest is computed by the formula I equal P times R. Again, T is replaced by T over 52. So the acquired value is computed by the formula F equal P plus I, which is P into 1 plus R times T over 52 by taking P as a common factor. And in this case, T is the time in weeks. As an exercise, calculate the interest and the future value of a capital of 5 million Lebanese liras placed at a simple interest rate of 10% for 130 weeks. The solution is P is 5 million, R is 10%, which is 0.1, and T is 130, which corresponds to weeks in this case. And the interest is I equal P times R times T over 52. Using this formula, we just replace T by its value in weeks. And the answer is 1,250,000 Lebanese liras. Calculating the future value, it is F equal P plus I, which is 5 million plus 1,250,000, which is 6,255,000 Lebanese liras. Now, sometimes we are asked to count the number of days. Counting the number of days, we should know the months, that we should know that some months have 31 days, others have 30 days, except February, which has 28 days for an ordinary year and 29 days in a leap year. Accordingly, we may have a problem as follows. So to count the number of days from May 16 to September 25 of the same year, what do we do? The number of days is 31 minus 16 plus 30 plus 31 plus 31 plus 25. Why? Because 31 is the actual number of days in May, but we have 16 days. We are starting from May 16, so we have to subtract 31 minus 16. We add 30 as the number of days of the actual number of days of June, 31 as the actual number of days of July, and 31 as the actual number of days of August, while 25 is the given number of days in September, because we end the period ends in September 25. Now, adding the number of days, I can use this number, which is 132. I can use it in a problem related to simple interest. The second part of this chapter is about compound interest. Defining compound interest, it is the interest that includes all of the accumulated interest of previous periods of a deposit or loan. We have a formula for the future value or the acquired value. We don't have a formula directly for the interest. Actually, it's deduced from the future value. The notation of the future value of a compound interest is computed by the formula F equals P into Y 1 plus I power N, where P is the initial capital, deposit, actual value or loan, R is the annual interest rate, T is the time in years, I is the interest rate per period, N is the number of periods during T years, K is the number of periods in 1 year. How to calculate I? I is R over K and N equal K times T. Note that if the interest is compounded annually, then K is 1. If it is compounded semi-annually, then K is 2. If it is compounded quarterly, then K is 4. Monthly, then K is 12. And weekly, then K is 52. This means that this is the number of periods per year. If it is daily, then as we have seen in the ordinary year, leap year, or in the commercial year, then K is either 365, 366, or 360. So if we go back to the activity at the beginning of the chapter, Nadim and Fadi, who had 10 million Lebanese liras and decided to place their money in a bank in 2 different accounts. Nadim at a simple interest rate of 10% for 3 years, and Fadi placed the 10 million at an annual interest rate of 9%, compounded monthly for 3 years also. The question was, who got more money, Fadi or Nadim? To solve the activity, Nadim, who placed the money at a simple interest rate, we calculate F, the future value, P into 1 plus R times T, which is, we replace P by its value, which is the 10 million. And we replace R by its value, which is 0.1 because the interest rate is 10%, and T by its value, it's 3 because we have 3 years. And the amount is 13 million Lebanese liras. What about Fadi? Fadi placed it at a compound interest, 9% compounded monthly for 3 years. The principal value is 10 million, R is 9%, which is 0.09, T is 3, which is the number of years, and K is 12 because it is compounded monthly. So we have 12 months in a year, and this is the period, the yearly period. Thus, I accordingly is R over K, which is 0.09 over 12. Which is 0.0075, and N equals TK, which is 12 times 3. This is equal to 36. The future value then is P into 1 plus I power N. 10 million into 1 plus 0.0075 power 36 equals 13,086,453.71 Lebanese liras. Then it's clear that Fadi got more money, earned more money. Why? Because 13,086,000 is more than 13 million. So using this calculation, we noticed that Fadi calculated or earned more money. The third part of the chapter is about annuities. An annuity is a series of payments made at equal periods, meaning years, months, semesters, etc. This series could be placed into a saving account to constitute a capital, means we are placing a fixed amount at equal periods of time in a bank, for example, or at an insurance company, or used to pay back a debt. For example, if we take a loan to buy a car, to buy a house, then we have to pay back this loan in equal amounts at equal periods of time. In this case, the future value, acquired value of a series of annuities, it's computed by the formula Fn equals R into 1 plus I power n minus 1 all over I. The earned interest in this case by this person is computed by the formula I equals Fn minus R times n. Why? Because here the person is earning an interest, not paying an interest. While in the actual value, the present value of a series of annuities, it's computed by the formula Cn equals R into 1 minus 1 plus I power minus n all over I. In this case, the person is paying an interest, and it is the way we use it to pay back a debt. The paid interest by the person in this case is computed by the formula I equal R times n minus Cn, where R is the periodic payment, meaning it is the amount of money paid every year, month, or semester. N is the number of periods. N is similar to that in the compound interest. And N is K times T. I is the interest rate per period, and I is R over. Let's solve an exercise on the acquired value of a series of annuities. Calculate the acquired value of a series of annuities, each equals to 500,000 Lebanese liras at an annual interest rate of 12%, compounded monthly for 5 years, and the interest gained. In order to solve the problem, we need to specify the given. Capital R is 500,000 Lebanese liras, which is the periodical payment. Small r is the annual interest rate, which is 12% equal to 0.12, equivalent to 0.12. T is the time in years, which is 5. And K is the number of periods per year, which is 12. N is K times T, which is 12 times 5 equal to 60. And I is R over K, which is 0.12 over 12 equal to 0.01. Here, note that we need to use the formula of the acquired value, which is capital Fn equals R into 1 plus I power n minus 1 over I. So substituting, we get F60 is equal to 500,000 into 1 plus 0.01 power 60 minus 1 over 0.01, which is 40,934,834.93 Lebanese liras. To calculate the interest gained in this case, and note that it is gained, it is I equal F60, which is the acquired value, minus the total number of payments, which is 40,934,834.93, minus R times N, which is 500,000 times 60. This is equal to 10,934,838.93 Lebanese liras. Let's take an example on the actual size of a series of annuities. To buy a car, Sami has to pay a sum of 600,000 Lebanese liras each month for 3 years at an annual interest rate of 9% compounded monthly. Determine the price of the car and the interest paid by Sami. To solve the problem, first we need to identify the given. Capital R, which is the periodical payment, it's 600,000 Lebanese liras. R, which is the annual interest rate, it's 9%, which is 0.09. The time in years is T, which is 3 years in this case, so T is 3. K is the number of periods per year, which is 12 in this case because they said in the problem compounded monthly. N is calculated by the formula K times T, which is 12 times 3 equals 36, and I equals R over K, which is 0.09 over 12 equal to 0.0075. In this case, of course, we need to use the formula related to the actual value. And here we have 36 annuities. So calculating C36, this is equal to R into 1 minus 1 plus I power minus N all over I. Substituting, we get 600,000 into 1 minus 1 plus 0.0075 all power minus 60 all over 0.0075. Using the calculator, the number is 18,868,083.15 Lebanese liras. To know the amount of interest paid by Sami, we use the formula I equal R times N, which is the total payments given to the bank minus C36 equals 600,000 times 36 minus 18,868,083.15, which is the actual price of the car, which is equal to 2,731,916.85 Lebanese liras. Thank you for listening and hope you have understood the lesson.